place end of November, beginning of December last year. Slightly different feel than usual, scaled back due to COVID. We also saw the first Adam Silipsky keynote after he took over from Andy Jassy. I think the main vibe or the main feedback we got is that it was, it felt more corporate. There was more sort of improvements as opposed to large swathes of brand new services being announced. But, let's look under the covers. So unfortunately, Lawrie is unwell, but I'm delighted to welcome Randall from Caylent to give us a rundown. So please drop any questions you have in the comments in the chat. We've scheduled a Q&A at the end. And we'll also be joined by Jim Carney then, hopefully, the CTO of Mobilize Cloud. And, they've been our main sponsor since day one for an exciting giveaway. And so with that, delighted to hand over to Randall.
All right. Hello, everybody. I hope no one minds my thick American accent. First of all, apologies for being late. That is entirely my fault. And I'm sorry that Ross wasn't able to join us today. I work at a company called Caylent. We're a cloud native consulting partner. If you want to reach out to me about consulting or anything like that, more than happy to chat. But this is not at all an advertisement or at all really about Caylent. And that's pretty much the last time I'm going to mention them. But please, do reach out if you have any questions. I'm going to hop right into things because we have a lot to cover and we're going to go very quickly. First, I'm going to talk about networking because I consider that the foundation of basically everything that happens in AWS. Then we're going to talk about compute, which is kind of the layer on top of the networking. We'll talk about storage. We'll talk about security, databases, analytics, and then we'll kind of pivot and talk about the developer experience. We'll talk about serverless architecture and migration patterns, and then we'll briefly go over AI and ML, mostly SageMaker there. And then we'll talk about IoT, and we'll blow through that section very quickly because it's a very broad set of services that are really built on top of a lot of the other foundational services that we're going to be talking about. So for the last probably 7 years, I have built a reInvent recap deck. I wanted to say that the deck that you're seeing today is mine, but many of the slides and many of the demos actually came from the AWS developer advocacy team. And I want to say a quick thank you to the developer advocacy team at AWS for building a lot of this stuff because it makes going out, consuming these announcements and understanding them very easy. So please buckle up. We're going to go quickly. I speak very quickly and feel free to ask questions. I'm going to kind of tab out and check those questions occasionally throughout the presentation. And if there's one that I can answer right away, I'll just answer it. Okie dokie. Everybody ready? Let's go. First, networking. So there are 26 launch regions, 8 more on the way. That means 84 availability zones, 17 local zones. Local zones are these kind of edge locations that are, availability zones without the same level of redundancy that you would expect in a traditional availability zone, which is something I'll talk a little bit more about later. There are 30 more of these on the way. There was a great talk at reInvent about a video game called Valorant created by Riot Games, where they talk about how they leverage local zones, outposts, and ISP edge locations to be able to get the latency they want for their gamers. That's linked in the speaker notes that I'll share later. There are 108 direct connect locations. This is growing steadily, and this is not quite as important as something else that I'll talk about later when we go into Cloud WAN, but 20 wavelength zones is kind of like private or 5G connectivity or mobile connectivity. 300 plus edge locations, 13 regional edge caches. That covers 90 plus cities, 47 countries, thousands of tier 1, 2, and 3 telecom peers globally. There's still quite a bit missing in Northern Africa. If you look at a map, you can see that AWS has pretty solid coverage everywhere except for Russia and Northern Africa. I expect that to improve over the next 3 to 4 years. All of this is powered by a fully redundant 100 gigabit per second parallel fiber network that circles the globe. That means they are making fundamental investments in their networking architecture, things like transatlantic and transpacific cables. These are undersea cables that connect the world. They invested in the Hawaii Kiki cable. They invested in the new cable from Turkey down to Africa. There are huge announcements that are happening here. I think one of the things that people miss in this network, and this is where it actually fundamentally differs with Azure, is they have peers and links with virtually every tier 1 provider at each of these internet exchange points. So if you're on AWS, you are getting an immediate tie into that backbone. if you've played any of the recent games from Microsoft that are now hosted on these Azure servers, you've seen the latency where they don't have the same level of peering relationships. Here's a quick map that kind of shows some of this. You can see where the edge locations are. You can see where these regional edge caches are. These regional edge caches, honestly, are basically availability zones. They're massive, massive deployments. I want to zoom in for a moment and look at what an availability zone is. A lot of people kind of have, different clouds use different terminology to refer to these things, but a fully scaled out availability zone is a highly redundant regional network with massive capacity. It's multiple buildings, multiple data centers. It is not a single data center. And then each availability zone, each region has 2+ availability zones. So some of the older regions only have those 2 availability zones, but every new region has 3 or more. There's one region in particular that has 6 or more availability zones. I think it's actually more than 6 now, but you can kind of guess which one that is. The largest availability zone, meaning individual availability zone, is 300,000 servers across in one single data center. And then that AZ is 14 different data centers. So these things are big. They are measured in terms of power. They are measured in terms of like megawatts consumed. And that's going to take us to some talks on sustainability later. But these availability zones, they're meaningfully separated, like not across the street from each other. They have, more than a mile, but less than the distance that speed of light would come into play. This protects each availability zone from things like fires, floods, natural disasters, or power infrastructure issues. And then, if you're interested in this kind of core fundamental networking stuff, the best place to learn about this is to watch James Hamilton's talks from prior years' reInvents. One thing that we want to dive deep on here is the networking capacity and the fundamental improvements that AWS invests in across their whole capacity, their whole networking stack. So if you have excess networking capacity, it gives you the ability to fail over and deal with infrastructure issues across the board. And in one of the largest regions, AWS has 388 unique fiber paths. I don't know if anybody's ever had to do networking, like laying fiber and planning and permitting and all this stuff before, but it's a little bit insane. And that aggregate fiber provides 5,000 terabits of capacity within that single region. This is what one of those cables looks like. On the left-hand side, you can see the original version of the cable, this is a standard 2-inch conduit. That one has 3,456 fiber pairs. What AWS did was they kind of made some investments. They have an applied photonics lab, and they were like, how can we put more fiber in the same conduit? And the other option, right, is to use like DWDM and put more data on a single fiber. But it's also easier, especially in metro fiber, to say like, hey, how can we just throw more fiber in the same conduit? So the one on the right is a cable that has 6,912 fiber pairs in that same 2-inch space. So I took this picture at reInvent this year, and in the background, you can kind of see this Nitro server and switching gear. And then here's that 2-inch conduit that I was just talking about. So this is what, the data center fiber kind of looks like. And then this is the stuff that they would use DWDM on to kind of do these longer range single fiber connections. So one of the big takeaways that I had from reInvent this year was that there was a big push for IPv6. This has been coming for a while, and there was no specific announcement about it. But when I, examined all of the announcements and all of the talks in aggregate, IPv6 seems to be a place where AWS is moving. This is great. I think this is really going to enable a lot of new workloads. Something that's a little frustrating is that while AWS is doing this huge IPv6 push, they're kind of lagging on the application layer protocols, things like QUIC or HTTP3. So other CDNs, for instance, already support HTTP3, whereas CloudFront still doesn't support it. There's a little bit of confusion about why they're making this huge investment in this lower level part of the stack, but not willing to make that same investment in the higher level part of the stack. And if anyone has insight there, I'd be happy to talk about it. So the big announcement going into reInvent was a huge data transfer price reduction. Again, this is mostly due to competition from providers like Oracle, Cloudflare, Azure, Google. And CloudFront now has 1 terabyte of data transfer out for free per month, perpetually, 10 million HPS requests, 2 million CloudFront function invocations. Keep in mind that CloudFront function invocation only covers the invocation cost, not the compute cost. So you still have to pay for that Lambda to run if it runs for a period of time. And then non-CloudFront egress has 100 gigabytes of data transfer out instead of 1 gigabyte data transfer out for free per month perpetually. So great work here. Really glad there's enough competition to kind of push this out. I hope it continues to improve, and I hope people continue to compete so that we can get better prices. Now, this was darned cool. So Cloud WAN is a wide area network, a software-defined network that will let you, as a network administrator, kind of manage your global infrastructure. Now, I've got a link in the speaker notes to the full talk on this. And there's something that you should kind of take away from this, which is that it does not currently work perfectly with transit gateways. So a Cloud WAN connection and a transit gateway are not like perfectly in sync right now. That's partially, my understanding is that that's partially why it's in preview. I would expect that as this, transit gateway integration improves, this comes out of preview and it becomes available for everybody. This is kind of an opinionated service. It's saying that, you're not going to do a ton of these weird site-to-site VPN connections and all this other stuff. Instead, you're going to have this one wide area network that is responsible for everything. And this is going to pair really, really well with IPv6. And I look forward to kind of seeing how this evolves. Netflix kind of talks about how there's a reInvent talk where Netflix will go through and talk about how they prefer a flat network topology. And I think this will enable a lot of that. All right. And there are a lot of great partners that worked on this too. So Aviatrix, Cisco Systems, Fortinet, Proximo, VMware, Aruba, a bunch. All right. Then there's SiteLink. So technically you could already do what SiteLink enables, but now you can use Direct Connect essentially as a transit network. So if you have multiple kinds of sites and places, but and multiple Direct Connect locations, previously you would have had to say, okay, now I need to set this route table so that everything is going to go through the AWS private backbone, and I'm not going to have to deal with any of my over the internet traffic and a non-Direct Connect location. Is essentially allowing you to leverage the AWS global networking infrastructure for your own traffic that remains within your kind of WAN. Transit Gateway launched intra-region peering. So Transit Gateway came out in 2018. It launched intra-region peering last year, or 2020. Intra-region peering came out in 2021. This is not like a huge value add, but where I do see this being particularly useful is if you're doing something like isolated infrastructure for on-prem or for like corporate IT stuff. And then you have your second isolated infrastructure for like prod web-facing traffic, or in the process of acquisitions. So let's say you acquire a company or you get bought by another company, having a transit gateway to kind of slowly migrate the services over so you don't have to do it all at once. This will allow you to keep business going during that process of like bringing in the new company. So nice quality of life improvement, but not like a huge gain. IP address management. This used to be done with Excel spreadsheets, basically, and now you can just do it right here in the VPC IP address manager. This one's really cool. So I was a little bit down on this when it initially came out. I thought it was really just going to be useful as a kind of debugging tool. I was very wrong. This is something that you can use in CI/CD. So this will tell you like, oh, I have an internet gateway. I need to go, through this security group. I need to go through this direct connect, or I need to go through this like table, this ARP table, whatever. And it will tell you how all of this is kind of connecting. I think this is a great launch that's going to really make debugging networks a lot more fun, and a lot easier. So good job to the AWS team. Private 5G launched. I don't have access to this. I haven't used it. My understanding from AWS is that it allows them to provide you with the 5G core, the radio access software, the cell radio access points, and then a SIM toolkit. And it will allow you to run like a factory or an airport or anywhere where you would want a private cell network. So partner managed firewall offerings. So gateway load balancers came out a little bit earlier, and this partner managed firewall offering is leveraging gateway load balancers. So I think gateway load balancer came out in 2020. I have not seen a lot of people doing stuff with this, so I want to point you towards FlowDog. And I'll that's not currently linked in my speaker notes, but if someone reminds me at the end of this talk, I will link to it. Gateway load balancer is heinously powerful. You can do so many things with it, and I'd like to see it leveraged in more architectures because I do believe it's very powerful, and I look forward to seeing what people do. So that's networking. Those are all the fun things that happened. A couple things that I haven't covered, things like 400 gigabit per second networking on some instances, as well as 800 gigabit per second networking on a couple of it on one of the AI/ML instances. And we'll talk about that now. All right, I'm just going to do a quick check, see if there are any questions. Let's see. Nope. All right. So moving into compute, just a refresher for anyone who has not seen like how these instances work and how you break them up. The first letter tends to be the instance family or instance type. The number after that tends to be the generation of the instance, meaning a C4 is powered by older Intel processors, a C5 is powered by newer Intel processors or AMD, whatever. The A on the end, or the suffix after the generation number, is the capability. So an A would mean it's an AMD, a G would mean Graviton, and I would mean Intel. If A and G are elided, it probably means Intel. Then you have other suffixes, things like D for instance store volumes, N for network optimization, B for block storage optimization, E for extra storage or memory, and Z for high frequency. And then you have a period, and then you have the size of the instance. This corresponds to the number of vCPUs and the amount of RAM that gets provisioned. There's a lot of different instance types these days. I don't even remember how many, but the way that you can think about it is that the AG and I cannot be combined. The AMD, the Graviton, the Intel, those can't be combined, whereas the D, N, B, Z, those can all be combined. And they're adding new stuff all the time. And unfortunately, not every instance follows this exact convention. So there's a little bit of confusion occasionally. So the first thing to talk about is the new Graviton 3 processor. So these are available on the C7G instances. They're in preview. I do not have access to these. I hear that there's a silicon shortage. Good old COVID is taking all the good things from us. So not enough silicon to go around. And the interesting thing to take away from this is that AWS has been investing in their own silicon. Apple's been investing in their own silicon. Microsoft is investing in their own silicon. Google's had their TPUs, which are their own silicon, for a while. Why is everyone doing this? And the reason is that x86 and Intel are great. AMD is great. They make awesome processors. They do amazing stuff. AMD in particular, with Lisa Su at the head, is just one of the most amazing companies I've seen. And it's great to see a leader like Lisa kind of involved in the silicon bring up and lab work. Like, that's crazy to see a CEO doing that. But this x86 instruction set is designed for general purpose computing, and workloads are becoming less and less general purpose and more differentiated and specialized, and are better served by different kinds of specialized silicon. The fact is, any kind of instruction you have to virtualize, any kind of work you have to do, that you have to create multiple instructions for. Like, let's say you have to do a matrix multiplication. If I have to load that into 2 registers and then run one hardware encoded instruction, that's vastly faster than saying, oh, I'm going to load into RAM, load from RAM into register, from register into this buffer, from register into this buffer, from cache into this. That's much faster to run the hardware instruction than to rely on compilers to generate all these kinds of other crazy sets of instructions that are good. Now, that's not to say that Intel isn't doing amazing work. Like, there's the AVX 512 instruction set, which can do all kinds of cool matrix math. But I think I've belabored this point enough. Specialized silicon is where a lot of things are moving. And the fact that AWS, they acquired this company called Annapurna Labs back in like 2014, 2016. It's hard to remember these days. Time is a construct. COVID is taken all the good things from us. The fact that they are able to come out with a third generation of Graviton just 2 years after they came out with Graviton 2 is impressive. And honestly, that might be why this is in preview. So just, going that quickly with Silicon is virtually unheard of in the industry. So it's not that I doubt AWS. It's just that there could be more to this preview story than we are being led to believe. This is the first cloud instance to feature GDDR5 memory. It's 25% better performance compared to Graviton 2, 2x higher floating point performance. One thing to take away from all of the compute that I'm about to talk about, and this was covered in both Werner and Peter DeSantis' keynotes at reInvent, is that don't rely on the sticker price or sticker performance numbers. You need to test these in real workloads. Charity Majors company Honeycomb has someone named Liz that launches a lot of their
Hey, Randall, I'm not sure what's happened, but something's just happened with the audio. So we can't hear you at the moment.
I'm going to switch to a different microphone. I don't know what happened there.
Yeah, you're back. You're back there.
Yeah. Can everybody hear me okay? Can you hear me okay?
Yeah, we can hear you now.
Sorry about that. I don't know. I noticed pretty much as soon as it happened, but I guess my microphone just died. Whatever. Okay. So jumping right back into things, yeah, I would strongly suggest checking out Liz's overview of how they used ARM and Graviton to improve performance across the board. All right, moving right along. Trying to move right along. Okay, so C5G instances are available now. These are ARM-based processors that also have NVIDIA Tensor cores on them. These are particularly good for running kind of like Android game simulations. They're also good for low-cost machine learning inference. These Tensor cores are pretty good at doing matrix multiplication, convolutions, those sorts of things. There's also the IM4GN and IS4GEN instances. These are Graviton 2 powered instances. So the I storage class instances, these are particularly good for running like Elasticsearch, MongoDB, Redis, like any like high memory and fast storage kind of service. These I instances kick butt at those. They have really, really fast SSDs attached to them that have very predictable performance. So EBS, as some of you may know, has great performance, but it is not always guaranteed performance. You can get like bursts and spikes even with the provisioned IO volumes, whereas these attached SSDs have, they're just for you, they're just for that server. You get great performance out of them. And I've seen MongoDB workloads running on these just humming right along, doing really cool stuff. The Graviton version of these instances is great because ARM is particularly well suited for a lot of those sorts of workloads that are, they don't need these specialized instruction sets like the AVX 512, and they take less power, they run a little more efficiently. And I've used these already. I'll go ahead and say like huge cost performance improvement for some of the customers that I've worked with. Jumping into the Mac instances. So the Mac Minis launched last year. That was a really cool video that they did, even though it was a virtual reInvent. And it was cool to see like a truck full of Mac Minis arriving and then, shoving some Nitro cards in there and letting that go. As I said, Apple's investing in their own silicon. These M1 Max, which is one of the things I'm running on right now, that might be why my microphone just died. These things are very, very cool. They do a lot of interesting work, and being able to run these in the cloud, as far as I'm aware, AWS is the only cloud that allows you to run these M1 instances. being able to simulate workloads and do CI/CD on these sorts of things is spectacular. The way that this is enabled is through the Nitro system. So Nitro is a hardware security model, a hardware I/O model with a Nitro chip and a Nitro card, as well as a software system that offloads a lot of that virtualization work, things that would have previously been in the hypervisor like Zen and or QEMU, like whatever your hypervisor is, like stuff that used to be done through that can now be offloaded to this Nitro card. I've seen a ton of great talks on this. I think Colm from AWS in particular has the best talk there, and I have that linked in my speaker notes if anyone's interested in learning more. There are also these X2I instances. These are really, really fast, really, really big instances. So the clock speed is useful for a lot of kind of query mechanisms, and they have a giant cache. I think it's something insane like a 10 megabyte L1 cache, or just something. I made that number up, but it's something that level of absurdity. They have great throughput to EBS, great networking performance. And these are, again, going to be good for those kind of SAP workloads, those HANA workloads. These will also be good for things like MongoDB, although they don't have that same network attached, that same kind of SSD storage that the I instances have. If anyone has an SAP workload that they're interested in migrating and they've used these, or they've used the previous generation of X instances, I would be very curious to hear about your experience, because it's hard to find a lot about this online, and it's not something that I've personally done. And I don't like when there's like a whole class of instances that I've never personally like used in prod. So if you have any stories to tell, please send them my way. I'd love to hear about it. All right, let's talk about the compute optimizer. So this is something that if you had an AWS support contract or an account manager, they would occasionally kind of send this to you. They'd say, hey, like you can create the savings plan. You can go and buy these instances, reserved instances, that sort of work. This does something pretty cool, which is it is not solely for compute. It will also look at EBS. It will also look at Lambda. And it will tell you like, hey, if you do this kind of savings plan, you'll save this much per month. And like, here are the options. It also is multi-region. So like it will look at things across organizations and across regions and tell you what you should do. I think this is a fantastic launch from AWS. I wish they'd done it years ago, but it's also a little hard to get some of this done. All right, then we have CloudWatch Metrics Insights. This is very, very cool. Some of this was already possible in CloudWatch, right? Like some of the stuff for like hybrid metrics from on-prem or other stuff, you could already do. You could already put whatever you wanted with put records in the API in CloudWatch. It costs money, but that you could already do. And then creating the visualizations that would auto-update, you could technically already do that. What I think is really darn cool is just being able to query this stuff in SQL, right? Great job making that editor and running all this. I've had access to this and run with it already. Phenomenal launch. I have no complaints, which is rare for me. So Bracket. So Bracket is kind of AWS's quantum computing service. Again, I haven't seen anything in production for this. Like I've played around with it myself. I know some of the people that are working on it. I think this is still early days. I do not know of any reason to go and invest a lot of time and effort into this right now. It's kind of like a hobby and toy project for you to gain familiarity with. If I'm wrong and there is a production workload running on this, I would love to hear about it and learn more. There are some reInvent talks on this that claim they're running in production, but they're still just doing simulation of quantum. So anyway, moving on to Outposts. So Outposts got a couple new form factors. So the one on the left you'll see is this 1 3/4 inches rack unit. This is an ARM-based server. And then the one on the right is a 2-unit, 3.5 inches tall. Those are Intel-based. So the one on the left is C6 GD instances, which means they are compute generation 6, Graviton, and storage. They have two 1900 gigabyte NVMe SSDs, 128 gigs of RAM, 64 vCPUs. The one on the right, this 2-unit one, these are C6 ID instances with Intel Xeon processors, Ice Lake generation, 3.5 gigahertz, and they come in two different capacity sizes, 16x large or 32x large, 128 vCPUs, 256 gigs of RAM, and 1900 gigabytes of NVMe SSD. So the storage is the same across both. The vCPU and RAM will change. These are pretty cool. I think this is a great launch. when I was talking earlier about that company Riot Games that launched this video game called Valorant, they talk about how they use Outposts really to expand their edge network. So they have co-location and data centers across the world, and they will shove some of these outposts in so that they can just basically expand their global AWS network. Again, going back to Cloud WAN, going back to SiteLink, going back to IPv6, I think if this expands, we'll get a much better idea of what the cloud means, right? The cloud is going to expand to not just be this single region or multi-region owned and operated kind of situation. If this kind of stuff can roll out globally to every data center, like AWS really is going to be everywhere. I'm looking forward to that sort of a future. These things can run EC2, ECS, AWS IoT, and a couple other services. And really all you do is you plug in fiber, you plug in power. I think they have redundant fiber, you just plug into the back, and cool stuff. Like I've worked with a couple customers on these sorts of things, and those big old racks are always fun to build and install and ship out, but it's nice that they have this smaller option now too, because I think it's very useful. Outposts have expanded into a couple more countries, Nigeria, Morocco, Ecuador, and Costa Rica. So it's nice to see Northern Africa getting a little bit more connectivity. I expect that trend to continue. I want to talk about Amazon Linux 2022. The previous versions of Amazon Linux are based on CentOS Core. CentOS, which is based kind of on like Red Hat, sort of, and they use Yum Package Manager, all this other good stuff. I think that people give a bad rap to Amazon for their open source contributions. I don't think people really understand how much Amazon does for open source. And I don't work for them anymore, so I can like boast about it, but you'll never hear this from anyone in Amazon, but like they really do contribute a lot back to the whole open source community. And like, yeah, they leverage open source, they sell those things as services, but at the same time, the fundamental infrastructure of the worldwide internet is built on open source contributions from large companies like Amazon, Facebook, Google, Microsoft. And so we should be a little bit kinder to all of the folks that work at those companies and make those contributions. We shouldn't just go on Twitter and badmouth them all the time. So that's my request for anyone watching this. So Amazon Linux 2022, it's based on Fedora. It is really, really good. Like, I don't know how else to describe it. Like, I've moved a couple of workloads onto this, just kind of playing around with it and trying it out. And I've gotten better performance, which is weird because it's not the latest kernel. It's not the best kind of, TCP window settings, everything, optimized out the yin yang, out the yazoo. Like, it's not like crazy optimized, but just by moving to this and installing a package, I have gotten better performance than I had on like Ubuntu, for instance. So very interesting, cool to see this investment. I look forward to seeing this continue. There was also workspaces for web. This is just workspaces that allow you to run in your Chrome browser. This is technically already possible. Alrighty, so are there any questions? Let's just see here. All right, nothing coming in. If there are any questions, I can stop at each section and kind of go through those. But since there aren't, I'm going to move right along. We're going to launch into storage. Give me 1 second to grab some water. Alrighty, going into storage. So S3 intelligent tiering has been around for a couple of years now. And what it's designed to do is, so I don't know if anyone remembers this, right? When intelligent tiering first launched, none of us were aware that by turning it on, we were going to be paying this huge cost to look at every single object in our buckets and determine the frequency. And so we ended up paying a lot of money accidentally just by turning on infrequent access. It's not infrequent access, intelligent tiering. It was concerning, right? Luckily, AWS went back and they were like, oh, sorry about that. We didn't realize like people have millions and millions of small objects in their buckets. So we're gonna warn you now before you do that, and we're gonna add a couple of little cost controls in there. So if you have millions of like less than 1 KB objects in your S3 buckets, be wary about turning on intelligent tiering. It is not for free. Now, if you have objects that are like 50 KB each, or higher, you can basically get an instantaneous cost savings by turning on intelligent tiering. And the new thing that came out at reInvent this year is this Glacier Instant Retrieval storage class. So Glacier is good in that it allows you to basically take like 90% off of your S3 storage costs, which is already quite cheap. And you can then say, hey, I'm not going to access this for years and years. I only have to keep it around for compliance reasons. So, I'll be willing to pay a retrieval performance cost and a retrieval cost just so that I can have a cheaper overall storage cost. What they've launched this year is instant retrieval. So this is Glacier storage cost in terms of dollars or euros or pounds, but at a regular performance, meaning you can retrieve this information as quickly as you need. I think this is phenomenal. I have no idea, honestly, how they built it. I kind of wonder if they're just like hiding or collecting the margin somewhere else, because it just doesn't seem like it's possible to build this in a profitable way to me. But anyway, good for them. Great launch. The way you should implement this is probably lifecycle policies, or you can use intelligent tiering. Intelligent tiering will move things to Glacier Instant Retrieval after 60 days, and it will move things to standard infrequent access after 30 days. So this will let you realize some pretty significant price reductions in your S3 costs. Okay, now we can move into EBS Snapshot Archive. So this is a great tool if you have to keep around EBS snapshots for audits or compliance reasons. You can say, instead of keeping this in the regular EBS snapshot storage, I'm going to, boom, move this over into Snapshot Archive, where I have a much lower storage cost. Like, I think it's like 75% lower or something. And then I'll pay, whatever cost I might need to pay to restore the snapshot into my regular EBS snapshots bucket. And depending on the size of these snapshots, so I think you can make, the largest volume you can make is still like 16 terabytes. It can take between 24 and 72 hours to restore the snapshot. So keep that in mind. Like this is a good fit for situations where you have archival compliance or regulatory needs. Not a good fit if you need instant access to those snapshots. Recycle bin for EBS snapshots. This is, again, particularly useful for any governance, compliance, or regulatory things that you might have going on. You can predefine how all this works with tags. What it will do is it will automatically keep the snapshots that you've tagged or set a rule for in a kind of recycle bin. So you can set the recycle bin retention period from anywhere between 24 hours to 1 year. And these rules can be like account-based or tag-based per region. And I think this is a great launch. This huge quality of life improvement is really going to help some of the junior and even senior operators who have made those fat finger errors before feel a little safer. I've got a funny story to tell about AWS GovCloud, EBS, and SpaceX, and Rocket Telemetry, if anyone ever wants to hear that. Anyway, Snowball's launched with Tape Gateway. This is Jeff Barr's dog on the left, and I think that's his office as well. Snowballs are really, really cool. We just did this migration with a customer where we shipped a Snowball over to them, and they moved a bunch of their workload, their storage onto a Snowball, and then we were able to move that into an RDS snapshot. They turned on write-ahead logging on their on-prem cluster, and then we were able to, like, with that write-ahead logging going, move into RDS, connect it as a replica, and then get everything running. I think those sorts of migrations are a lot of fun, and it involves all kinds of cool complexities, like, oh, how many hours do we have? Oh, we have 72 hours to get this thing from the on-prem to the data center while we still have the write-ahead log. It's just fun stuff. There's a tape gateway, is a thing that AWS launched a while back and is part of the storage gateway service. I don't use tapes. I don't really know anyone who still uses tapes, but the fact that they have enabled this is pretty cool. These have a ridiculous amount of storage in them. And I think if you're still using tapes, honestly, like, you should question your architecture. Or maybe not. Call me, I'll help. All right. So then we run into FSX for Lustre. So there wasn't any particular announcement at reInvent for FSX for Lustre. Lustre, if you've never used it, is kind of a high performance file system, typically used in like supercomputers or batch computing. I used it a lot when I was at NASA. It's particularly useful for kind of, I have a bunch of different machines that need to access all the same stuff, but it's not going to be a particularly write-heavy workload, or all the writes are going to be going to different places. This is leveraging the 400 gigabit per second networking. It's a nice kind of cost reduction that was available too. And the big thing for me here is that it has a lot of S3 integration that was not previously there. If you have questions about Lustre or you want to deploy it, reach out. I'd love to hear about it, even if you just have some war stories to tell. So I ran a ZFS cluster at SpaceX, and we used it for a telemetry system. ZFS is phenomenally powerful, but a huge pain in the butt to run. It's also hard to get set up right initially. So if you're deploying ZFS for the first time, or if you have your own existing ZFS, it's kind of special sauce. We have all these wheels tuned exactly the way we want them. Running ZFS on AWS has always been like an interesting experiment. The fact that this is now a managed service through FSX, very cool. I think this will allow for a lot of really cool fast workloads. There's a company called Weka.io. I don't know if anyone's ever heard of them, but they make their own kind of storage service that's really high performance, good for AI ML workloads, and built on top of AWS. This is AWS S3 and VMware integration. We'll skip over that just for the purposes of time. And now we're going to move into security. So Amazon Inspector, very powerful. This is an agent that can be installed on your containers, like as a sidecar, or on EC2 as just a regular agent, very similar to AWS Systems Manager agent. And in fact, you can install Amazon Inspector as a SSM command. So if you already have the SSM agent and you want to install Inspector, it's just one command, boom, run. This is powerful, but it's not like these capabilities are not already there and like provided by partners and things like that. I think one of the things to take away from the Inspector launch is that AWS is trying to provide their own set of tools that you can trust within your compute environments, but there's also like the well-architected component to consider, which is can you run untrusted compute anyway and like not even have to worry about this, like ephemeral or untrusted compute like Lambda or blow away containers, that sort of thing. So different workloads have different constraints. The fact this integrates nicely with I'm on the wrong slide, I apologize. This integrates nicely with organizations. It will push all of the things that it detects and finds within your instances, like open ports or intrusion detection. It'll push all that up to Security Hub. You can add suppression filters to say like, hey, I don't really care like about these sorts of notifications. Yes, I know this is supposed to be open. And the nice thing about pushing this to Security Hub and InventBridge is that you can trigger step functions workflows for kind of like automated remediation. I don't know anyone who's doing some of the automated remediation work yet. So previously we did things with like AWS config, right? And we would have config trigger a Lambda, which would trigger like some sort of workflow and do automated remediation from there. That gets really hard, right? Like there are only specific applications, contexts, and environments where that automated remediation is good. A lot of times people will over rely on automation for these use cases. Here's kind of like the Randall advice here. If you get a lot of these kinds of alerts, yes, you have to pursue automation and categorization. If you're only getting these occasionally, I would recommend just staffing a human being. A human being has critical thinking and can like reason about why this is coming in. And they can read a run book and they can apply, logic to the situation. So having someone on payroll and having someone that can be paged will get you 90% of the way there. The automation is hard to build and hard to get right. And I've seen whole massive pieces of infrastructure be taken down by automation and automatic remediation before. So you have to be very careful in the way that you deploy these sorts of things. Control Tower got a couple new capabilities. You can centrally provision resources. You can share the resources. This is mostly done these days through RAM, Resource Access Manager. You can optimize your costs, compute optimizer and other things, so savings plans can be implemented at a master account level and then pushed down to all the other accounts, and integration with all of the other services. Control Tower got data residency controls. This is really useful in regions like the UK and Germany, where you have specific data residency requirements. If you're working in one of these regulated environments and you've used these data residency controls, I would love to chat with you and hear your story, because this is not something that we deal with super often in the US. We mostly deal with two different compliance regimes. One is ITAR, in which only US citizens are allowed to work on and access the data. It's the International Traffic and Arms Reduction Treaty. And it's a vestigial structure. It's based on like nuclear proliferation agreements from like the 1960s. And the modern version of ITAR says like, oh, you can't work on rockets because you were born in Canada, which is completely absurd. And it's really frustrating to see these like antiquated laws getting in the way of technological progress. So that's really the only data residency issues I've ever had to deal with. I haven't ever had to deal with some of the global government stuff. So I'd love to hear, what kind of constraints and issues you run into there. Then we have web application firewall support for CAPTCHA. Great. You could already implement this with kind of like Lambda edge functions. You could do like a 301 redirect to a CAPTCHA, and on success of the CAPTCHA, you could go and say like, boom, all right, I want you to go and redirect to the original service. This is nice because now it's a checkbox, right? Like instead of having to write all that stuff or just deploy it like from a CDK construct or whatever, boom, turn it on, done. WAF has DDoS mitigation. So DDoS mitigation is in a lot of different layers of the AWS stack. This is just expanding that to kind of layer 7 stuff, so the HTTP kind of world. And then before we move on to talk about databases, I wanted to take one more moment to say on the networking side, I have an ask of AWS, which is please, like, let's get moving on HTTP3. So HTTP3 is the quick protocol. It's UDP based instead of TCP based, but UDP is becoming more and more reliable. You'll see that a lot of the instances that are talked about in the Peter DeSantis and Matt Wood and Swami keynotes from reInvent this year, they use reliable datagram protocol, RDP, and they use that because UDP on like a fiber network, you're not worried about dropping packets. You don't need to do this complicated handshake, and you can do like, hey, my application layer is responsible for assembling all these packets and then sending the right stuff back out. Whereas TCP has a lot of flow control and like a lot of, like, oh, we're going to do a send, act, boom, da da da, back and forth. I think HTTP3, Uber's using it, Facebook's using it, Lyft is using it, all these mobile apps are using it. The fact that it's not available in CloudFront yet just frustrates me, because I want to use CloudFront for everything, but I end up having to use other CDNs to be able to deliver the performance that I want for my end customers. So make that request. And for what it's worth, the CloudFront PM on Twitter replied and said, yeah, we're working on it. So please keep working on it. I'm really excited about it. And I hope it'll be there in ALB as well. And that's one more thing. And I'm going to go on one more networking rant. I'm sorry. AWS does a lot of like network translation layer stuff. So in ALB, for instance, all of those HTTP2 requests to get translated down into HTTP1 requests for your endpoints that ALB is talking to. It'd be nice to have a seamless run through, right? Like HTTP3, HTTP2, just going all the way to my compute. And then streaming responses from Lambda. I want that too. So thanks, AWS. And thanks for everything you do, but there's always more. All right, jumping into databases. I love databases, probably my favorite topic to talk about. The person to follow here, the real OG, is Rick Houlihan. So if you've not seen his talks before on DynamoDB or other databases, he's over at MongoDB now. MongoDB is doing a bunch of really cool stuff in the database world and also in the cloud world. So I would suggest following Rick Houlihan, listening to his talks. Everything I'm about to tell you is really just his stuff in my own words. The other person to follow at AWS in terms of databases is Joseph Spizak. He's the general manager and PM for a couple of different database services, and just all around really, really smart guy. Has a handle on all the database workloads that are going on out there. So if we look at the way databases evolved over the years, we go with Oracle starting out, we get DB2, we get SQL. Edgar Cod comes out and back in the 70s and is like, okay, this is how we're going to do normal form. This is how we're going to do DDL, and then SQL gets proposed on top of that. If you read the actual papers, you'll find like no one really liked SQL back then, but somehow it became like the de facto language that we all use now. And then Access, which is not really a database, MySQL, Postgres. Anyone know why MySQL and MariaDB are called what they are? So interestingly, they are both named after the daughters of the person who invented them. So MySQL and Maria, invented by the same person, one named after the first daughter, and then the other one named after Maria, the second daughter. Fun fact. So, and then, we get into like this lull that happens after the dot-com boom. And it's not like databases aren't coming out then, right? Like the Mark Logic is around here somewhere. But the problem in this time period, right, is like XML. XML is like the de facto transport protocol. JSON isn't how we're doing things yet. JavaScript hasn't become prevalent. We're still in like the DHTML era and CGI bin era. And so everything basically sucks. And we're stuck kind of like reinventing the wheel 100 different times. And then, the Dynamo paper comes out in 2007, and then Cassandra gets built as kind of an open source implementation of that Dynamo paper. MongoDB comes out, which is really like, if you think back, if you harken back to like these 1980s, like this goes back to the PIC database, the denormalized database. It was created for helicopter parts. And MongoDB is like that same version of like, hey, I want to access build documents. And it's kind of arose out of this idea, like, we've been screwing around with MySQL and Postgres, and we've been trying to make these things scale, or we've been trying to make Oracle scale, and we don't want to fork over a ton of money to Oracle to just run their hardware that we still have to have a giant support contract for. And so I really think that, all the great databases that came out in these 2000 time period, like this, we were barking up the wrong tree for about 8 years here. And then when the Dynamo paper came out, when we built MongoDB for the first time, that's when we started getting back on track in terms of databases. And then we got things like Redis or Anti-Res, we got Elasticsearch, DynamoDB, Aurora, Neptune, TimeStream. I'm a little down on TimeStream still. QLDB for ledger databases, and DocumentDB, which is MongoDB built on top of a like Postgres style storage layer, Aurora style storage layer. The interesting thing about databases in the cloud is that you can do things that would not otherwise be possible. And I'll talk a little bit more about that in a minute. But the reason that we build these databases this way these days is that the applications and the access patterns that people have are very different. So back in the 70s, storage was expensive. These days, storage is cheap, but compute is expensive. So we have to scale in a different way than we used to. And we have applications that have petabytes and exabytes of volume, global access. We have to replicate data all around the world so that it can get fast access. People want their data in single-digit milliseconds, even microseconds, millions of requests per second, device-generated data. And it's not just web applications. It's like IoT work. It has to be able to scale up and scale down. And you also want to be able to get this at a price that is efficient. And you also don't want to have to make your application know about 1 million different endpoints and access points, like a JDBC connection string that's like 2 pages long. Like you don't want that. So there's been a lot of great investment in this field, lots of new data structures and fundamental computer science investments, CRDTs, all this good stuff. I think when it comes down to it, we cannot solve the problem of speed of light. At least I don't know how. Physics is not able to be overcome. So we have to reason from the first principles of physics. We have the speed of light limitation. We have this fiber connectivity limitation. What can we provide that gets us as close to the ideal as possible? And there's a lot of cool innovations that allow that. So AWS has been going on this kick recently of like purpose-built databases. I believe in this to an extent, right? Like if you have relational data, you can use relational databases, and all data is really relational. But like let's say you need like referential integrity and ACID and other kinds of things. You can use Aurora, you can use RDS, you can use all this other stuff. Let's say you need a key value store, but it needs to be like low latency in memory kind of deal. Then you would use Elasticache, right? You use Redis Memcached, or now MemoryDB, which launched at reinvent, or slightly before reinvent, sorry. And then let's say you need a document store, which is kind of like this nice in between relational and key value, in that you get a lot of the benefits of that key value store, but you get the documents in a denormalized form that's really easy to work with in your application. Then you can use DocumentDB, MongoDB, DynamoDB. These all work with that. The complication is, with MongoDB, you're paying these instance costs, or DocumentDB, you're paying these instance costs. With DynamoDB, it's essentially serverless in that you're paying on demand or per request. So being able to query things in memory, great, all good. Graph databases, Neptune is cool. People had implemented TitanDB on top of DynamoDB before that. It's kind of interesting, but like I still like I've used Neptune in production for some interesting use cases, but it's never like this could not have been done without Neptune. So that's kind of the frustration I had is I'm always looking for like Neptune is the only possible way I could have solved this problem, and I've never really found that. So if you have something that Neptune was the only possible way you could solve it, I would love to hear about it. I think that'd be a cool story to tell. And then we have time series databases. The real best time series database that I found out there is actually not an AWS product. It is ClickHouse by Yandex. It's a Russian company. It's phenomenal. TimeStream, we can talk about TimeStream in a bit. And then ledger databases. I like QLDB. I think it's great. I think they've built some cool stuff on top of it, and there's some great reInvent talks on it. RDS Custom launched at reInvent this year. This is the ability to take your kind of special sauce custom servers for Oracle or SQL, bring them into RDS. I have not used this. I'm curious to find out how much it costs. I wasn't really able to find much pricing online. Be interested to hear what people have done and how it works. DevOps Guru. This is straight up cool. I was kind of down on this originally because it was being billed as like a DBA as a service. And I thought that was kind of like marketing mumbo jumbo. It's not. It really does have some pretty solid insights to provide about your workloads. So I've used it in prod now, so I regret my previous words about how this was a stupid kind of thing to build, and you can't really get DB as a service. It turns out you can. So the nice things it'll do, it'll say like, oh, you're running out of connections, you need to up your connection limits, or like, oh, you should create an index on this. Right now, it only works for Aurora, Postgres, and MySQL, but other RDS engines are coming this year. And these notifications from DevOps Guru, they can go into SNS and EventBridge, and you can just kind of take action on those from there. Great launch. Good job, AWS. Peter DeSantis talks about in his keynote the value of aggregate workloads and being able to do reasoning across large swaths of workloads. I think that's worth watching if this is the sort of stuff that interests you. Okay, I think this was a little bit mumbled or fumbled in terms of the way that it was talked about at reInvent and the way that the launch went off. Everyone I've spoken to has not fully understood what infrequent access table class is within DynamoDB. So DynamoDB, you pay per request normally. You can do provision capacity and stuff too. And you have this like on-demand table that you're just saying, okay, I want to access this. I will pay this read cost, this write cost, whatever. Read capacity unit, write capacity unit. Infrequent access is going to save you money when the OLTP cost of your workload, meaning the read capacity units and the write capacity units, are here, and then your storage cost is here. So what that here is about 50%. So when your storage cost becomes 50% of your overall DynamoDB cost, you should consider infrequent access. There's no performance change. Well, so Amazon claims there's no performance change. I saw some interesting performance characteristics when I switched to infrequent access. So I take that claim with a little bit of a grain of salt. So maybe trust but verify. And I didn't test this at like particularly huge load, right? Like I didn't go to millions of requests per second or anything, but I did kind of run it. The other interesting thing about this is that you can change table classes once every 24 hours. So if you have a workload that 50% of your storage cost in Dynamo is there, or 50% of your overall Dynamo cost is storage, you move it into infrequent access, you start saving that money. But then you're like, oh, actually, I need to load this into Glue, or I need to load this into S3, or I need to process this whole workload, or trigger a giant table scan, something like that. You can move it back to the regular table class and get, with no downtime, just get that immediate OLTP better performance. So what you're doing with infrequent access, you're trading the transactional OLTP read and write capacity unit cost for the storage cost. That's how to think about it. I hope that was clear. As I said, TimeStream, it's GA. It went GA before reInvent. This thing was announced in like 2017, and it's pretty expensive. Half the time when I do these like window functions or aggregate functions, like it doesn't work, and I don't know if I'm stupid and I'm using it wrong, or if it just genuinely doesn't work. If anyone's used this in production successfully, I'd love to hear your story, but I still I have a hard time recommending customers use this because I just can't get it to do what I need it to do, and the cost is a little bit prohibitive. So this is darned cool. Redshift serverless. So Redshift, you typically provision one, your compute nodes, two, your storage nodes, and then you get this access mechanism. So I don't know how many people know the history of Redshift, but it was originally like this crazy cool C++ engine that was acquired by AWS back in like 2011 or something. I don't know, pretty early on. And it was all rewritten and redone. And Redshift has just had a lot of really cool investment over the years. And you have Snowflake, you have other kinds of data warehouses. I have still working with all these data warehouses over the years and using this at scale. I can say I still recommend Redshift. There's a tremendous amount of flexibility and a tremendous amount of capability within Redshift. And the fact that you no longer have to think about the provisioning of the underlying resources, big win. So great launch from AWS. I've used this a little bit, but mostly on someone else's computer because my AWS account doesn't have access yet. So if you have access and you want to get me into the preview, let's talk. This is going to be really, really useful for kind of like business admins who don't necessarily have a great understanding of like how you need to provision storage nodes and like compute nodes. It'll do a lot of like query optimization and all kinds of other good stuff, which kind of takes me to the next Redshift launch, which is materialized views get auto refresh, which is that's great and normal and good job. But the really cool thing is the query rewrite. So this will look across multiple different storage engines. Like if you're using external tables through Spectrum or like other federated tables that Redshift needs to access, it'll say, hey, I know that I have an index into this, and I know that I expect this many rows to be returned based on previous queries. So let me go in and rewrite this query to take advantage of the existing index that I have. Very, very cool. So the query optimizer, it essentially will automatically leverage materialized views to like process queries and rewrite them to take advantage of this stuff. So cool launch, good job. This is probably my favorite recent feature. So there was a earlier version of like the query editor that was available in a couple different AWS consoles where it was a nice little SQL interface. It was available in CloudWatch. It was available in a couple other services. This is version 2 of that. So this is going gangbusters, saying like I can query anything just through my AWS console. I don't have to pop anything else open. You can talk to EMR, you can talk to Redshift, you can talk to whatever you need to. This is fun to use. It's really well done. It's got some nice autocomplete. So another good launch. DMS Fleet Advisor. This is good because DMS database migration service. I've used this for a lot of different customer workloads, and it's an amazing service with a couple of random like pain points. So just like all these little random gotchas that are buried deep in the documentation. It takes some getting used to, but it also saves you a lot of time. So what DMS Fleet Advisor does is it'll automatically collect some statistics and some telemetry about the data that you have, whether it's on-prem or otherwise, and it'll say, okay, cool. We know that you have 700 tables. We know that you have 40 indexes. We know that you are growing your data by like 10 megabytes per day, or 10 gigabytes per day. So this is what we're going to recommend in terms of source endpoints, target endpoints, and migration tasks. So interesting stuff. Lots more to be done here. So looking forward to seeing more that capability there. Database migration service also got time travel. This only works for Postgres and MySQL, but it really helps you like debug some of these migration tasks, like stored procedure fails to migrate. Oh, why? It's well, Post Aurora doesn't have this particular function implemented. You can just go through and do that. All right, moving on to analytics. The data exchange API is pretty powerful. This is now available in the AWS SDKs, so you can pop open and talk to like marketplace APIs or other data exchange APIs. Really, really simplifies the governance of these things because now you're using IAM to kind of get at this data. So cool launch. I haven't really used this in prod. I did play around with it just on my local computer. It works. I don't have much to share there yet. Lake formation governed tables, another great launch. One thing to take away from this is that the row and cell level access policies are the key kind of feature here, right? Like governed tables where you have, data residency or compliance or whatever else that needs to be kind of moved away or kept in a particular place. That was already possible through IAM and config roles and stuff like that. Granular level access control is enabled by like a new version of Presto, is my guess. So Athena got ACID transactions. This uses the Apache Iceberg format, and you can make row level modifications to Amazon S3 data. This is going to be really, 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 really cool. Like if you think about the way that we deal with S3 today, we consider it mostly like a key blob storage with some nice query capabilities on top of it. This turns S3, instead of a key blob storage, into a fully functional database. Can't wait to do some more stuff with this. And then, there were great improvements across Athena as a whole. And again, this is mostly enabled through Presto upgrades, and AWS contributes back up to Presto as well. These storage APIs are interesting. All right, and EMR went serverless as well. So same sort of deal as Redshift. You don't have to think about what the underlying compute is. Of course, you pay a little bit of a premium for that. Again, good launch. Just it's the logical evolution of auto scaling is serverless, right? Like, hey, I've got enough intelligence about your workload to know exactly how much capacity I need to provision. So rather than making you worry about the underlying compute infrastructure and capacity, let us manage it for you and let us take a little bit of margin on that for that kind of convenience. Managed Kafka has serverless availability now. This one is very cool. So Kinesis data streams has what they're essentially describing as like a like on demand, or they said on demand, but you can almost think of it as like serverless. Previously, if you wanted to use Kinesis data streams, you had to provision shards, and shards would provide individually 1 megabyte read, 1 megabyte write and 2 megabyte read capacity per shard. And you had to make sure that you were leveraging your shards correctly across your whole workload. This says, hey, don't worry about provisioning a certain amount of shards. Like we will automatically do that for you. And so in on-demand mode, you pay for throughput consumed rather than provisioned resources. So it's a lot easier to balance your kind of cost and performance there. All right, let me take a drink of water and then we'll launch into serverless. Are there any questions so far? I know it's a lot. All right, jumping right into serverless. So previously with Lambda, if you wanted to filter events, you would have to pay for the cost of invoking that Lambda every single time. So you would say, okay, I'm going to look at every single event, and then I'm going to try and close Lambda as quickly as possible if I don't need to make any action on this event. This was cost. It increased your costs. And Lambda's like, oh, wait, all this data is coming in as JSON anyway. Like, just put your pattern that you're filtering by into your event source mapping, and we will cover that cost for you. So for Kinesis data streams, DynamoDB streams, and SQS, you can now say when this data comes in, and only invoke my Lambda function if it matches a certain pattern, and otherwise, the event doesn't get triggered. So this is pretty darn cool, right? Like, pardon me. You're now no longer having to pay that cost. So thanks to Lambda team, love this launch. Partial batch responses for SQS. So previously, if you were doing batching with SQS and you had stuff come in, you would have to go and manually re-enqueue the failed things or manually send to a DL queue the failed messages. Now, if an individual item fails, as part of the Lambda response, you can just say, okay, this one queue failed, or this one message in the queue failed, but the rest of it did not. So it'll automatically send it to like the redrive or whatever it needs to. Okay, so S3 was kind of the first event source that I know of for Lambda. I would, the S3 kind of Lambda event notification API is all the way back in 2014, right? So things have evolved a lot within AWS since then. Using Event Bridge as opposed to using those other APIs is probably the way to go from now on. So I would say this is how you build modern event-driven architectures, is with EventBridge, not with these other like event source mapping APIs that used to happen. And I mean, it still uses the event source mapping API, but now, you can trigger whatever kind of thing you want. You can set whatever patterns you want, and you can do a lot of kind of reasoning about that and see these kinds of event rules in a centralized place. Offset lag for Kafka, it's not particularly important. So this was a pre-announcement. So you can now provision additional ephemeral storage within Lambda. You could already attach like EFS. So you could attach like a shared file system and do like multi-read, multi-write on that. This is saying, hey, I want more temp storage. So you get 512 megabytes by default. This is giving you up to 10 gigs, and you can provision in 1 megabyte increments. And it's available for both the deployment zip as well as the, whatever other stuff you would want to load it. Just keep in mind, as great and as good as cold start improvements have been, if you go and make a 10 gigabyte zip file, your cold start for a Lambda function is not going to be instantaneous, right? Because you have to pay on a cold container to get that package like copied over and put on that machine. So growing this as much as you want, it doesn't come for free. Just keep that in mind. EventBridge has cross-region support. Great, awesome. Step functions got a nice little tie-in with the Athena console. So no new features here, but like a nice little quality of life thing. Sync Express, which is an invocation mode for step functions, has private link support. Probably should launch with this. SQS, as I said, has DLQ automatic read drive now. It's good. It also has managed or KMS capabilities. You can use the AWS provided keys. There's a great talk on like how KMS works with different services and how they provision keys for customers and what the parent and root authorities and all that good stuff is. If you're interested, I would strongly suggest checking that out. Moving to developers and DevOps, we get Code Guru Reviewer. This is pretty cool. They add more features to this time after time. They recently added hard-coded secrets detection. It'll do things beyond that too. It'll say like, oh, like, hey, you're accessing a cache, but you're not, setting it, or like, hey, you're recreating client connection handler every single time when you should just be creating it in a parent and then using it across your threads, all that good stuff. Terraform support for AWS Control Tower. So Caylent was somewhat involved in this, and I'm a big CDK guy. I love Terraform too. Like it's a great piece of software, but it's nice to see that you can now do a lot of Control Tower work through Terraform. But as I said, I'm big on CDK, and I know that's a controversial opinion. So we can chat about it. Like I was saying before, AWS does a ton of work in open source. They contribute quite a bit. They contribute Kubernetes, Containerd, etcd, FluentBit, OpenTelemetry, KSCTL, Notary, V2, OCI. And then AWS has also made a big move into Rust. So Firecracker and BottleRocket are kind of containerization runtimes and microservice, micro VM kind of formats. These are written in Rust and Go. Carpenter is a Kubernetes scheduler that's kind of AWS aware. CDK and CDK-AS are open source projects that allow you to do infrastructure as code with real code, like completions, all this other good stuff. And then Amazon Linux, which we talked about earlier. AWS Amplify going into reInvent, they got a new GraphQL transformer, which works a lot better for single table designs. There's this in-app messaging powered by Pinpoint. I wouldn't use this yet. It doesn't really work. Intercom or like HubSpot or those sorts of integrations are still kind of the way to go there. I'm hopeful that this improves though. Like I think this could be a thing. It could work really well. It's just not quite there yet. So looking forward to that. Amplify Studio. This is probably one of my favorite launches from reInvent. So you can design something in Figma, bring it into Amplify Studio, and create the React code, which is like human readable code, not like the kind of stuff that you get from like Expo or DraftBits, where it's like, pixel aligned X, Y minus 40. No, this is, it has the flexes, it has all the box models, all this other good stuff. So very cool to see this. I didn't believe that it worked, so then I went and I tried it out, and I was pleasantly surprised to find out that it does work. It works particularly well if you use their UI components. It does not work as well if you're using like your own custom UI components. CDK v2, this is CDK packaged just monolith, and it has a couple new capabilities like CDK watch, pipelines, and assertions. The other thing here is that you get a couple of nice things for deploying code without redeploying the whole infrastructure here. And you can use, for those of you who've never used CDK before, you can write your infrastructure as code which gets synthesized into CloudFormation templates. You can write it all as like TypeScript, Java, Python, .NET, and Go. I would strongly suggest just using TypeScript. The other APIs that are provided in the other languages, they are provided through JSII, which is an interpretation language that will generate the SDKs for these other languages, and it does not always work. I've hit major issues with Python CDK before, and so at these days, I just do everything right in TypeScript. And TypeScript is a beautiful, very elegant, well-designed language. Microsoft has done a lot of good work there. There's the CDK Construct Hub. This has CDK Terraform support too. There's some nice tags in here. You can kind of filter by like which version of the CDK or which thing you're going to run with. There's a lot of stuff in here, and one of the things that I kind of want to see here is the ability to like upvote. You know, like you can see how many downloads there are, but there's no like, oh, this is the one I would use. It's kind of like the WordPress plugin market, you know, where there are like 100 different plugins that all do the same thing, and you're not sure exactly which one to install, so you just install the one with the most downloads. I'd love to see like a voting feature that says, oh, this is great, I love this, or a commenting feature at least. CloudWatch launched real user monitoring. This is kind of like Ghost Journeys if you ever use that service. It's you can kind of see what's happening in your application in real time. It's a piece of JavaScript you throw onto your site, and it will track, you know, performance and use across your pages. So some interesting stuff goes on here in terms of cookies and user journeys and all that. I played around with this. I like it a lot. I think they did a good job on it. The frustration I have right now is that I use X-Ray in a lot of the work that I do, and the X-Ray trace IDs are great for the backend, but I've always had this issue of tying the X-Ray trace IDs from a front-end user to a backend request. And I was really hopeful that this would do that, but it doesn't. That said, at reInvent, they said that this was going to get integrated so that the X-Ray trace ID generated on the front end could be propagated all the way through to the back end. Once that's done, once that works, you can imagine you'll have some really cool workloads and opportunities. There's also CloudWatch. Evidently, this is kind of like LaunchDarkly. It'll let you do A/B testing. So AWS App Config and Systems Manager already supported feature flags, and you can do this a lot for your backend. Evidently, will work for both the backend and the front end, and it's got the different SDKs supported. Cool launch. I feel like I could already do most of the stuff that was in this though. Microservices extractor for .NET, so this leverages .NET Core and some of the DDD stuff that is in .NET to be able to easily extract out services. There are new SDKs. There's Swift, there's Caylent, there's Rust. I think the Rust SDK in particular is super cool. Also, the Swift SDK. Congratulations to a former colleague of mine, Nick Keystone, who built and launched that. I think she did amazing work. The interesting thing about these new SDKs is they're built on top of something called the CRT, the Common Runtime Environment. There's a good talk on this from reInvent this year that is linked to in my speaker notes. The Common Runtime Environment is C++ implementation of IAM networking and a couple of other things. Very cool way of leveraging some of that common like networking functionality and security functionality into these higher level languages. You can manage a couple new resources from Slack. Carpenter came out. This is a scheduler in Kubernetes for AWS EKS and EC2. It'll basically just leverage EC2 autoscaling groups. I have not quite used this in prod yet. I do have a project coming up where I'm using it, and I would be able to tell you more about it right after that. So, you know, I would say go check it out, but like I said, haven't quite used this yet, so hard to really give any advice or guidance there. Pull through cache repositories are pretty good. So if you've used AWS Code Artifact or any of the other tools that kind of will manage NPM and will manage pip and those sorts of things for you, this is doing a lot of that similar capability where you have, you know, your dependencies and your containers and your ECR repo, but it can also pull through from like Docker Hub and things like that. So it's always a good practice to have these sorts of things going on. Marketplace will now allow you to deploy these ECS and EKS kind of workload marketplace offerings to Outposts and, you know, other environments that are even off of AWS. Repos. So Repos is interesting. This is replacing the AWS Forums. So AWS Forums, I'm sure many of us have spent some time there and gone there and done stuff. So far, I have not been impressed by what I've seen on here. Theoretically, AWS employees and AWS support are going to come and like answer things. There's a lot of noise. There are a lot of like kind of dumb questions on there that could be solved really easily by just like a Google search. And then the really hard questions are ones that, like I don't think anybody knows the right answer to. And so what I think AWS should do here is they should do the same thing that Stack Overflow does in terms of this is how you ask a question. Like, and talk about the XY problem where, you're asking X, but you really should be asking about Y. And there needs to be a little bit more user education before people just go and ask these questions, because a lot of these things just, it's really hard to come up with an answer for something with so little context. So I hope this grows and I hope this takes off. But so far, I think there needs to be a little more education for the users. Bug bust, we're just gonna skip over that. A couple more announcements. I'm not going to go over each of these. The one I do want to talk about is Corretto. As many of you know, there was a Log4j vulnerability that was in prod in a lot of different services across the world. Not like I'm not saying AWS, but just like generally across the world. Corretto was able to hot patch that like in 2 days. And they also have this new Shenandoah GC model, which has much better performance and throughput and predictable performance too. There's architecture. There was a new architecture lens in terms of sustainability. Adrian Cockcroft talked a little bit about this, and then there are a lot of other great people at AWS that are working on sustainability. As a large corporation, when they talk about sustainability, it's a little bit, I don't know, it always comes across as weird. That said, I think some of the investments that AWS is making in renewable energy are pretty cool. They have some nice goals around 2025 in renewable energy, and you can read about that on their sustainability page. Wallet Protected now has custom lenses as well. In terms of migration, there's this mainframe modernization framework and tooling that kind of got announced. AWS keeps talking mainframe modernization every single reInvent since 2017. I don't really care about these workloads, right? Like they're going to have to move come hell or high water into modern applications, and like IBM Z2 mainframes, like they can still sell them, but you can still use DB2 if you want to, but like eventually the talent around COBOL and DB2 is going to retire and age out, or the people learning it are going to be like, wait, why wouldn't I just use Mongo? Why wouldn't I use something else? So I don't really know that you need a framework or anything around this. Sometimes as an organization, you just have to pay the cost. You just got to bite the bullet and get it done. Then Migration Hub React Factor Spaces. I like this a lot because it lets you use this iterative extraction capabilities and the Strangler Fig pattern to go and refactor your environment. A lot of people will do the like replatform component lift and shift model, but then they don't really rewrite their applications afterwards to take advantage of the cloud. They only do that for greenfield applications. So lift and shift is great, but eventually you want to go and like you want to refactor the whole thing. Moving to AI and ML, the way that AWS thinks about ML, at the bottom layer, you have your frameworks and infrastructure. These are EC2 networking, your FPGAs, your fast file systems, all this other good stuff. On top of that, you got the ML services. These are things like EMR, SageMaker, Canvas, all this other good stuff. And then on top of those, you have the core AI services, things like Lex, Poly, Transcribe, Recognition, Translate, Comprehend, TextJack. These are all API accessible services, Comprehend. And then on top of that, you kind of have these kind of specialized things like forecast and personalized fraud detector, all this other good stuff. Whew. So looking into the infrastructure side, we have these TRN1 instances. These are good for training. So you can use the Neuron SDK to kind of compile stuff into a format that these TRN1 instances can take advantage of. I've used this quite a bit, and I used to work on the PyTorch project. It doesn't really work that well. You still have to do a lot of manual work. Like the Neuron SDK, one, it doesn't let you use the latest versions of either TensorFlow or PyTorch and the latest versions of those models. It doesn't really work very well with ONNX or anything either. But these TRN1 instances are pretty darn cool. Like you get 800 gigabit per second networking, Trainium chips are built in, and just really, really fast, really, really cool and very performant. But like I said, like to really take advantage of that silicon, you kind of have to do some magic There's SignTune is an open source project for hyperparameter optimization that AWS released, moving one level up from the stack. We have SageMaker. SageMaker is a big investment area for AWS right now. You can see they're kind of moving into these lower code environments or no code environments where these business analysts are having access to SageMaker and AutoML capabilities. So notebooks are now available. This is something that was already available in Google Colab or Azure Notebooks before those got deprecated and taken away. SageMaker notebooks are kind of that idea of like, hey, I want to be able to share and do these notebooks without really creating an AWS account. So it's pretty powerful. Training compiler, like I said, this kind of uses a Neuron SDK to take advantage of training enhancements. And like I said, it works okay for like bog standard models, but the second you get into anything complex, you run into issues. Inference recommender, I haven't used this, but theoretically what it does is it says this is like the kind of underlying compute that you should provision to be able to serve these inferences at scale. There's serverless inference. This one is particularly cool. I really like this. This is saying, I don't care about the underlying compute. I just want to pay per request. This could be really, really good for scale up, scale down workloads where you're not doing inferences all the time. I really want to use this. I haven't had a chance to use it in prod yet, but I'm going to as soon as I get a spare moment. ML ops. So this is not really like service or launch as a whole. It's more just like a way of thinking about SageMaker and how different things integrate. Then there's Ground Truth Plus, which is like Mechanical Turk plus for labeling your data. There's SageMaker Canvas. This is the kind of no-code, low-code environment for maybe non-machine learning folks to go in and generate ML models, to generate ML inferences. Played around with this, pretty good. I don't have a need for it personally. I've worked with some customers who have asked about it and played around with it. I can see this being useful. SageMaker Studio Lab, this is what I was talking about within your notebooks, where you can kind of like, without signing up for an AWS account, you can go and get a notebook. It comes with like 15 gigs of storage, security, and it's just like a free ML environment. This is really something that I wish I'd launched a long time ago with Collab. And then we get into the AI services. We have new launches from TextJack, new launches from Personalize. Kyndra remains very, very expensive. It's hard for me to recommend Kyndra to customers just because of that expense. Kyndra got this capability to leverage Lambda functions to go out and enhance documents. You can run recognition, text extraction, add comprehend on those. You can still design your kind of search function. Like I think Kyndra is darn powerful, really, really cool. It's too expensive. Like if you have the money to spend on it, it's absolutely the right thing to use. But a lot of times you're stuck like just using Elasticsearch and some custom apps. All right. Chatbot Designer is pretty cool. This will analyze transcripts from your chats with agents and things like that and automatically extract out the verbs and build out the chatbot for you. Obviously, it doesn't do the implementation part. So even though it can do the analyze, you can't, you still have to implement the logic and stuff behind it. There's also an ML scholarship program that AWS announced. And we move into IoT. I'm going to go through this really fast because I want to get to some questions. IoT Express Link is a new piece of hardware that came out from AWS reInvent. This is the ability to get some of the built-in Greengrass and IoT kind of IAM and other connectivity stuff right on a piece of hardware. These are the ones that are available. There's TwinMaker, which allows you to view your IoT device in a simulated environment. It's particularly good for like a Roomba, for example. Then you have, this is an example of what that might look like. Pretty cool piece of software. I'm interested to see a lot more happening there and what that ends up looking like. There's also IoT FleetWise. I have no idea who is using this. I have no need for it, but this is like for managing autonomous vehicles, and it integrates directly with like the CAN bus of different cars. Interesting. Then there's IoT RoboRunner. This really simplifies manufacturing IoT workloads. So if you have a lot of different robots from a lot of different manufacturers, you can kind of go in and say, okay, I'm going to use one system as the work management system and one IoT core kind of thing as my means of orchestration and management. There's also the Robotic Startup Accelerator. There's Greengrass integrations with Systems Manager, so you can install the Greengrass agent from Systems Manager, a couple other things. There's the Greengrass software catalog that's on GitHub. There's RTOS, got like 10-year support now, and it's got some out-of-the-box connectivity stuff available. And yeah, like I said, the 10-year support. And that is it. I know I went a little bit over time there. Thanks everyone for sticking around. We can end it if we need to.
Yeah, so that was you weren't joking when you said it was going to be a whistle stop run through of all the announcements. So yeah, no, that was fantastic. Thanks so much for that. There was a question earlier on from Rod Jones, which was basically, any chance of getting Inspector for Lambda. So this is when you're talking about, the effectively the enhanced Inspector service. So something's being re-architected.
So Inspector runs as an agent on a compute node or like a sidecar container or an EC2 instance. So for Lambda, you don't really need it, right? Because for Lambda, you're not managing that operating system or open connections or anything. You're just doing like, boom, I'm spinning up the compute and then I'm running my code and then you're done. So I don't see a huge need for Inspector in Lambda.
Cool. So I'll keep an eye on the if there's any last minute questions coming in. One thing I did notice, you're talking about time stream. One thing that came as a surprise, not sure if you've come across Zach Cantor and the team at Steady. I think he's so actually they're quite big users of time stream.
Oh, really? I'd be interested to learn more about that. I really would love to see it used in prod. There's a thing I'll share called FlowDog that someone else at Steady made. Aiden Steele. Paste this link here. So this uses that gateway load balancer that I was talking about earlier, and just shows you a couple of the cool things you can do with rewriting traffic and stuff.
Cool. I'll copy that into the main. Yeah. So then in terms of, I was going to ask you there are a couple of questions that people tend to, we call them sort of like the Marmite, quite opinionated. So one of them was going to be in terms of things like CDK. I know there's a bunch. Obviously, you seem to be a fan of CDK, and obviously the CDK book got launched. Matt Coulter got recognition from Werner. V2 CDK came out, so it appears you're a fan of CDK.
I am, and I was not originally. So in the early days, maybe back in 2017, I was just as down on CDK as other folks. And then I've used it now for a couple different production workloads, and I'm a convert. I think it's really good. I vouch for it.
And then what about local testing? So things like local stack versus always testing in the cloud. Have a view on that?
Yeah, I think, unit testing is good. For integration testing, I think nothing really beats a developer environment that's kind of a replication of your prod environment in the cloud. You can use things like fault injector service for a couple of different failure modes to kind of test that stuff out. Local stack is great for kind of like development and quick local test, but I would not rely on it to be an exact implementation or an exact representation of your integration testing environment.
And then you rattle through so many new features, releasements, and enhancements. What was the one announcement that excited you the most that came out of reInvent?
I think overall 400 gigabit per second networking was a pretty big deal. I really like that. And I think if we continue to improve on that, networking speed and networking capability, it's just going to unlock so many cool things. The other kind of cool announcement for me was the SageMaker notebooks. The like anyone can just spin up a notebook.
Yeah. And then for us, where we are in South Wales, we have a lot of, there's a lot of sort of software engineering focused universities. A lot of people, there's a lot of areas that originally were heavy industry, and people are trying to sort of change the area and get more into a tech focus. So would you, in terms of your background, when you look at things like Mongo and SpaceX and AWS and now Caylent and so on, is there any advice you'd give for someone that's looking to get into, cloud computing?
Yeah, there's nothing like hands-on training. So Quick Labs and A Cloud Guru, they have these lab environments you can spin up and you can really just get your hands into the code. The other thing is doing it just for the sake of learning it is not enough. The way that I've always forced myself to learn something is by giving myself a deadline and giving myself a project. And the project has to be something that you're personally passionate about, not like, I'm going to spin up a static website. It needs to do something that you personally care about. Like if you care about cancer research, build a tool to like research, collate cancer research papers. If you care about baseball or soccer or football, build something to track your favorite football club. You have to have a project that's going to be a forcing function to make you learn things. So autodidact kind of systems are great, but those forcing functions, they do so much more.
Cool, fantastic. And then finally, what we find, there's so much, so many meetups and sort of online conferences and so on now that, a lot of the traffic that we get ends up people watching back. So, watching the playback on YouTube. So imagine people watching it, there may well be questions that come out, you don't think of them at the time. So, it's when you watch it back that you, I wish I'd asked that. So finally, if people do have questions and want to reach out to you, what's the best way of doing that?
I'm pretty responsive on Twitter, so JR Hunt on Twitter. I probably spend way too much time on Twitter. The other way to reach out to me is Randall, Randall at Caylent.com. I get a lot of messages, so it might take me a little bit to reply. If you have a low latency question, maybe ping me on Twitter. I'll get back to you faster.
Fantastic. And so with that, thank you so much for coming along and giving us that amazing recap of reInvent. Take care, everyone, and we'll speak to you all soon.
Thanks so much for having me. Bye.